Hey, Miss Sparks.
Hey, Brookie, how are you?
Good. You said you
Good.
needed a picture to review?
Yes,
Okay, I'll see if I can email you that.
you're so sweet.
Yeah,
I
it's like,
had I've had a number of students email me about the review. It
yeah,
seems like a remainder, the most of the questions come from the last half. So if you don't want to
yeah,
send me the first, that's fine. You
yeah,
could send me, let's see, like like 30. I feel like let me double check my email. I feel like it's like 30 something forward.
yeah. We like checked in class through problem 31, so I can send you like 32 through 62.
Okay. Because I was going to say, it seems like I got one email that said like 54 to 62, and I got another
Yeah,
email that said had the 30s in it.
yeah. I'll see if I can send you that.
And if not, what I did before I got on here was I kind of outlined the chapter, and I was just going to go through concept by concept if I didn't,
Okay.
you know, if I didn't get pictures of it. Um, so I was going to try that at least.
Okay.
Mostly trying to focus on 2.4 to 2.7 because that seemed to be where
Yeah.
most of the questions were coming from. I'm trying to find the other email. I think I got 3 emails from your class.
Okay.
Um,
I think I just sent you one. We'll see
okay.
if I.
Sometimes when it's a picture, it takes a minute to hit the email. But I've got my email on my other, yeah, 37 through 62. And then,
Yeah, I'm about to.
hey, Gabriella, how
Hey,
are you?
I'm good.
Good. Um, uh, the other class has a different review, so I'm going to try to hit theirs and ours.
Oh,
Um,
okay.
do you have a specific question?
Um,
Because Brooke is she's helping the other class out by sending me pictures right now of the other review. I got
oh,
I got one, Brooke.
Okay. Hopefully the other one is coming to
Is
you.
the Hey, Brooke, is the other one all one page?
Yeah.
Okay, so you only need to send me 2 pages?
Yeah.
Oh, cool. Um, Bella, did you have specific questions on our test review?
yes. I was kind of confused on number 16,
Okay.
or
And
like,
I was going to say, I bet that that's probably the same like concept that they're asking me to do. Yeah, that's one of the ones that they're having me cover. So I'll make sure that I cover that. Let me open Brooks so I have everything open.
okay.
And then, oh, this one doesn't have anything in it.
My second.
Brooke. Oh, wait. Yeah, it doesn't look like that one has any. It didn't come.
Okay, I'll try it again.
Sorry, sweetie.
No, you're fine.
Yeah. All right. While you're sending that, I'm going to go ahead and try to work number 16 over here. Okay. On this one,
Like I say,
the zeros. So if I'm going to turn those into factors, that's going to be x. Oops. X minus 2, x plus 3, and then x. I'm sorry, I'm factoring this in my head. I'm factoring it in my head. It's interesting. This one should come in conjugate pairs.
Oh, okay.
So I don't know if that was kind of a trick question and they were expecting you guys to know that. Because when it's imaginary, it's going to come in conjugate pairs. That's one of the principles that we learned in 2.7.
Yeah.
So, and the reason for that is that it has to factor out that middle part. Does that make sense?
I
Is
think
that
so.
is
I
that the
kind
part
of
that
remember.
kind of tripped you up by chance? Okay. Now that you have that, would it make more sense?
Yeah, but I'm so confused like what you do next after you have that.
Oh, I'm so sorry. Okay. Well, this down here, I would go ahead. This is basically the difference of two squares. So this is going to be x squared. And then remember the middle two, when you FOIL this out here, the middle two terms would cancel out, right?
Yeah.
Because it would be plus 3ix minus 3ix kind of thing.
Yeah.
So that would cancel out. So then you would have a minus 9i squared, which then turns into I squared is a negative 1. So negative 9 times negative 1 is going to be plus 9.
Okay.
Okay, so there's that part. And then x minus 2 times x plus 3. I would FOIL this to be x squared plus x minus 6. And then you distribute the x squared to both of these. So you've got x to the 4th. I'm actually distributing this x squared plus 9. So I've got x to the 4th plus x to the 3rd minus 6x squared. I'm going to run out of room. Are you following what I'm doing or no?
Yes, I am.
You are? Okay. All right. And now I'm going to distribute the 9 all the way across. So that's going to give me plus 9x squared plus 9x minus 54. So now I'm going to combine like terms, which the only like term that I really have are the x squareds. So I have an x to the 4th, did I miss something? Okay, x to the 4th plus x cubed, and then minus 6x squared plus 9x squared is going to give me a plus 3x squared plus 9x minus 54.
Okay. Is that the answer?
Yes, ma'am.
Oh, okay. That makes sense.
Okay. All right. Sorry about that. I probably would have warned about that. I don't think there's anything like that on the test. Like I say, most of the time I make the review harder than the test.
Yeah.
I think that there's an imaginary, like if you have to write a polynomial tomorrow, which I'll look that up. Hold on just a minute. If you have to write a polynomial tomorrow, I don't think there's an imaginary. Oh. That we'll just leave it at that is the answer. There is one. And the one tomorrow on the test is very similar to this.
Oh, okay.
Okay.
And
Oh,
then
I got
is
it.
there
You did? Okay, I
I
sent it
did
with
get
my
it. Yes.
other.
I'm sorry, Bella. What was your
oh no,
question?
for 21, is it the same thing with like the root? Like, because the root kind of messes me up too. I'm not really sure.
Yes, it is the exact same thing with the root. And that one is this one is a little trickier just because you're going to have something squirrely that looks like this. Plus, and then -3 plus square root of 5. And then that's going to be one of the factors. And then this is going to be the other factor. So it's squirrelier to, what am I trying to say? To FOIL, but it still works because your second term cancels out. So basically what you've got then is a 9 plus 5. On that. Because this is like a whole term. So once you square this, just that piece, I'm trying to explain it where it will actually make sense. These are definitely harder than these, I think, because of the whole conjugate concept. But basically now you've got a 9 plus 5, which is going to be what? Help me out. 14. Did I do that right? 9. Hang on just a minute. Maybe I did. $45. Yeah, I'll have to work that one completely out. I'm sorry. I'm gonna have to look up. I have it worked out somewhere else, but I am gonna have to work this one completely out on there. I'm gonna have to foil it all the way, but that's what the partial foil looks like. So I will work that one completely out for you.
Okay, thank you so
But
much.
it's gonna take way more paper than what I just had.
Oh.
But you got this one?
Yeah, I understand that one.
Okay. All right. So yeah, we'll work that one. All right. I'm going to open the others and kind of start backward. And Bella, even if I send you that one or I post it on our Google Classroom with it completely worked out, that's what I'll do.
Okay.
But I looked on there and I promise I don't have one of those. But those always come in conjugate pairs. And that was the primary principle behind, like, this will be a conjugate pair and this will be a conjugate pair. And that was that principle behind 2.7.
Yeah.
So your zeros would be x plus or minus 2i and then x plus or minus -3 plus 5, the root 5.
Okay.
And I will, but I don't want to, since I absolutely know neither one of those are going to be on the test tomorrow, I don't want to use a lot of math lab time on that. But I do want you to know how to do it because you asked the question. Does that make sense?
Yeah, that makes sense. That sounds good.
Miss Burke,
Okay. Yes.
did you say that the conjugate pair stuff is not going to be on the test?
The only way that the conjugate pair stuff is going to be on the test is the one, number 16. I don't know if you made it in time to see me work that. You will definitely have to know how to do that one.
Okay, so I set it up x minus 2, and then x plus 3, and then x plus 3i and x minus 3i. Is that right?
That's perfect.
Okay.
That's perfect. The ones that aren't quite as complex, like I do understand, like if there was going to be a root on there, and there isn't, but if there's going to be a root on there, I would do something more like that. I wouldn't do the one where you're actually having to do this stuff. Does that make sense?
Yeah.
I figure if y'all can learn how to do this piece and understand that they come in conjugate pairs, in pre-calc, you'll get the other.
Okay.
I want y'all to practice doing it this year, but y'all will master it next year. So I want to test you on the fact, for me, knowing that this imaginary numbers and the irrational numbers come in conjugate pairs is the principle that I really want to drive home, that concept that I really want to drive home.
Okay.
Okay. So, and when you're finding the real zeros and you get those, that's important to know.
So for number 16, I just solved it out real quick. I'm multiplying the x plus 3i and x minus 3i. So I got x squared, and then would that be a plus 3?
It'd be a plus 9.
Oh, okay. Because you have a 3 from both of them.
Yes, ma'am.
How do you get a 3 from both of them?
Well, technically, when you're doing x plus 3i and x minus 3i, the middle term cancels out, right?
Right.
But your final term is 9i squared.
Oh, okay. And that would equal plus 9.
Because this right here is a -1. So you've
Right.
got -9 times -1.
Okay.
Does that make sense?
Yeah, that makes
Okay.
sense. Thank you.
All right. I'm going to open. The other day I was the other day I was able to open. There it is. I don't know. Can y'all see that? Why won't it let me rotate? Well, okay. This will help me to at least get the problems. Brooke, you're doing great.
For some of them, I am, but I feel like, I don't know. Once you get to like 22 down. That's where I'm like struggling.
Okay. All right, let's take a look at well, when you're evaluating, okay, when you're evaluating the functions, like, so are you understanding 29, 30, 31, 32, where you're given a value like this -3, like you had, and you applied synthetic division, which you did great.
Yeah.
And if there's a remainder, it's not a zero.
Right.
If there's no remainder, that it is a zero. So you have that, right?
Mm-hmm.
Okay. All right. So that's good. You're doing good there. And then dividing on here, you needed to, do you prefer long division or synthetic?
Synthetic.
Okay. So when it says to divide here, you'll, if you're using synthetic, you'll use 7. And then you're going to take your coefficients, which is 1, -16. You want to make sure that they're all, going in a row.
Yeah.
I mean, so you got 3, 2, 1, and then none.
Mm-hmm.
And then 1 times 7 is 7.
Mm-hmm.
And then -16 plus 7, that's going to be 9, -9.
Yeah.
And -9 times 7 is -63.
Mm-hmm.
And then 62 plus a -63 is -1. And -1 times 7 is -7. So you have a remainder of 2.
Yeah.
So your answer, oh, I see. You have it written there. So you're fine because this is your remainder right here written over the 202.
Yeah.
You did great on those. So are you good on that concept?
Yeah, I'm good on that. It's more like on the last page.
Okay, and how about factoring? You looks like you did great on all your factoring.
Yeah, I was wondering if you could work 38 out for me.
38?
Yeah, I like got the signs wrong when I did it the first time.
Yes, so this one is the correct one because
Ms.
what
Clark?
you're doing is yes?
Are you going to be recording this math lab?
Yes.
Okay, good. I had a lot of other things I needed to do, and I was wondering if I could come back and watch it.
Yes. I'll
Okay,
post
thanks.
it. Uh-huh. What you're trying to do is find the factors that multiply that give you 2, a positive 2,
Mm-hmm.
but when you add them, give you a -3.
Right.
So you've got 2 and 1, so you were right there. But 2 and 1 add to give me a +3. So they need to be negative in order to give me a -3.
Okay.
So you got to watch what you're looking for basically is what when you combine them, like you need to watch the signs.
Right. Okay.
Okay.
Mm-hmm.
So if you have a negative here, right here, then these are one factor is going to be positive and one factor is going to be negative.
Mm-hmm.
But if you have a positive, both can be negative or both can be positive.
Okay. Are you working this somewhere? Because I can still see like the picture I sent.
I actually brought it into a program called Cami.
Okay.
And can you not see me making notations on it?
No, I just see like your email like thing with
Oh, goodness. I'm glad that you said something.
But I was following you. You were talking about.
Oh, bless your heart. That's crazy. Because, yeah, I totally was writing all over that thing. I don't even know where it is now. Thanks for letting me know.
Yeah.
We'll try this one more time. You writing on it now?
Yeah, now you're good.
Okay. All right. So what I had basically said is this, if that's positive
Uh-huh.
and this is negative, then you know both of your factors are going to be negative.
Okay.
This positive and this positive, both of your factors are going to be positive.
Okay.
Here, both are going to be negative because I know it takes two negatives to make a positive. So
Right.
you really, when it's factoring, you just have to watch, you just have to watch your signs.
Okay.
All right.
Mhm.
All right. Any more questions on factoring?
I don't think so.
How are you all doing ones like 41 and 42?
We're doing the AC method.
The what?
Like the AC method. Like
Oh, okay. So like
10 and the
this and then this. Okay.
kind of.
Working okay?
Yeah.
I don't want to confuse you and give you another one before the test.
Yeah, we just write it like for 41. You just like put an arrow down from 10 and 18 and then you multiply 10 and 18 together. Like well, I guess that's
For
40.
number 41, 10
No.
and 5.
Is that what you asked about? 40?
Of 42 or 41?
Okay. Well, for 41. Yeah, I did the AC method. So like you just like pull down arrows from 10 to 5 and then you multiply that so you get 50 and then you're looking for what multiplies to get 50 but to get positive 27.
Yes, ma'am.
Yeah, and then you just write and then you pull down the squared and the 10 5 and then you group it. Like factor by group.
Okay. You factor by grouping. Okay. All right. All right. Great. I just wanted to make sure you were solid on those.
Yeah.
How you do it.
Got that down pretty well.
Okay. Good. I do it slightly different, but whatever works is the best thing to do.
Yeah.
All right. Now I'm going to pull in the other image that you had.
Okay.
And then for those who are in my class, I want to find out what specific ones that you guys, I know Bella, we're going to finish that one that you asked about. And I didn't know if my class had other ones.
Miss Sparks, when you get a chance, can you go over number 20 on the chapter test B thing?
Yes, I can. Is that the graphing one?
Yes, ma'am.
Okay.
Miss Sparks,
Yes.
I was just wondering what I should do for the worksheet because I wasn't there on Monday.
Oh, the chapter test B, I sent it to you.
Oh, you did?
Yes, sir, I did.
Is it on?
I actually sent it via an email to you. So let me know if you didn't get it. It was in response to the email that you sent me, and I emailed back. But I sometimes when lots of people email you back, it gets lost in the shuffle. So just let me know.
Okay.
If you get it. Sorry. Technology is a blessing and a curse. I think I finally got it. Yes, praise the Lord. Is Benjamin's
find it.
You did get it?
I couldn't find it. It wasn't on.
Oh, you couldn't find it?
No, ma'am.
Okay. 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 I think what I'm going to do is skip to numbers 49 and 50 and then go back to some of the factoring ones. Unless just because I know these were questions that more people asked about. So I want to cover that first in Math Lab and then go backwards. And then I'm going to skip to number 20. But I'm trying to hit the ones, I'm trying to hit the meat of what the number of questions that I got emailed about. But stating the possible rational zeros, this is chapter or section 2.6 in the chapter, and we were kind of building on the concept of looking for the possibilities of what the zeros or solutions are. And these are rational, and I want to kind of highlight that point because later on we find out that you can have irrational zeros as well as imaginary zeros. So I want to point out that this is the rational zeros. So that means that they can be stated in fraction form. And this is where you can kind of see on Brooke's work where she has the P and the Q, and the P is the constant at the end, and the Q is the leading coefficient of the first term. So once again, when working with polynomials, the first thing that you want to do is you want to make sure that your polynomial is in order, starting with the highest decreed term first.
Miss
And both 49 and 50 are. Yes.
I can't see your screen.
You can't. Oh,
Like what you're working.
bless you.
Sorry.
No, no, no. I'm glad you're stopping me before I go on.
Okay.
Now, can we see?
Yeah.
All right. It's going to vanish if I don't do this. All right. So 49 and 50. So P over Q, you've got all the factors of 1 and then all the factors of 2. So here you have plus and minus. I usually write it like this. I'm going to write it down here in this free space. You got all the factors of 1, which are going to be plus and minus 1, over all the factors of 2. So you think of all the different ways that that can be written. So it can be written as 1 over 1, which is 1, 1 over 2, and that's pretty much it. And you can see the answer there is plus or minus. And a lot of times, a lot of mathematicians, and I always joke about the fact that mathematicians have a tendency to be lazy. So they'll really write it just like this. They'll do the plus or minus out front and then just list all their terms. But it's probably a more effective way of doing it like this, like Brooke has it. So then number 50. P over Q is all the factors of 5 over all the factors of 3. So we've got plus or minus 5 and 1 and plus or minus 3 and 1. So that could be 5 over 3, 5 over 1, 1 over 3, and 1 over 1. And that's all plus or minus.
Mm-hmm.
So that would actually, once you reduce all of your fractions, you would have plus or minus 1, plus or minus 5, plus or minus 1/3, and plus or minus 1 or 5/3. Okay, does that make sense to everybody? Any questions about rational zeros and finding the possibilities? For my class, that is going to correspond to number 14. So where you're listing the possible rational zeros here, you've got P over Q, and then you've got plus or minus 6, plus or minus 1, plus or minus 3, and plus or minus 2. And then the factors of 2 are plus or minus 2, plus or minus 1. So then you would list them as you've got 6 over 2, which reduces to 3, but we'll put that in our list. And then you've got 6 over 1. Then you've got 1 over 2, 1 over 1. Then you've got 3 over 2 and 3 over 1. And then 2 over 2 and 2 over 1. So your full list would look like this: 3 plus or minus 3, plus or minus 6, plus or minus 1/2, plus or minus 1, plus or minus 3/2, Plus or minus 3 is already there. Plus or minus 1 is already there. And then you would also have plus or minus 2. So that's your full list for number 14. So listing all of the possible rational zeros is you're literally taking the factors of that constant and the factors of the 1. And those are rational zeros. So that does not include the possible, and those are to help you narrow down the possibilities of what the zeros and solutions are. Also, when you're using the graph to kind of help you do that, you can be like, is that in my list of possible rational zeros? So you kind of use those two in combination with each other to figure out what some of the zeros are so that you can narrow it down to the number of complex and or irrational zeros that you have. Does that make sense to you guys?
Yeah.
Okay. Is Rachel still with us?
I am.
Did that make sense for you, Rachel?
Yeah, that makes sense. I understand that.
Okay. Because I know what can get confusing is when you start stacking these different concepts on there and you're thinking about, what is the difference between the rational zero theorem and then finding all of the zeros? Because once you start getting all of the zeros, you're looking at some of the imaginary and irrational ones.
Okay.
So, and we started stacking that concept on in like the latter part of 2.6 and then on into 2.7. Definitely 2.7 for the irrational and the complex. Let's see. Let me go back. This just seemed to be this section here, and the zeros seem to be the most asked questions. So I'm kind of moving back and forth. This here says state the possible number of positive and negative zeros for each function.
Yeah.
So this is where we're using the Descartes rule, which came out in 2.7. So you're actually looking for sign changes.
Mm-hmm.
So the first one on number 51, you're just going to look at the polynomial as is. Okay. And so you're going from here to here, and there's only one sign change.
Right.
One sign change. Can you see it?
Mm-hmm.
Okay. So that is your positive for the one sign change. Oops. For the one sign change, there's one positive possibility of a positive zero. Then what you're supposed to do is plug in f of x, f of negative x, if you will. So what I'm going to do is I'm going to have negative x raised to the 6th minus 64. So what happens if I raise a negative number to the power of 6? Is it positive or negative in the end? So if I multiply x times x, negative x times 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 negative x, I think I said 6, I'm still going to be positive at the end. So I still only have one sign change for negative. And the other concept that we kind of piggybacked onto that, there's one negative sign change or one negative zero possibility. Okay. And what we piggybacked onto that was if you think about, and I'm not absolutely sure that Miss Wynn's class got to here, but my class definitely got to here.
Mm-hmm.
If you look at that number right there, that's 6. That tells you the total number of zeros that are a possibility for this problem.
Oh, okay.
Okay.
Mm-hmm.
So if there's one positive and one negative, that tells me there's still 4 open. So my class needed to know that there's 4 imaginary.
Right.
So there could be 4, 2, or 0 imaginary for that one. Because it adds up to be 6.
Okay.
But I think Miss Wynn's class only needed to know the positive and negative, but I'm not sure. What is that what she talked about, Brooke? Did she talk about imaginary zeros?
Yeah,
Or no?
she like touched on it, but I don't think she like.
She's not going to put it on the test.
I don't.
Okay. I'm not sure. I can't remember if the answer for mine is if that's on there or not. I need to double check that. But basically, the synopsis of it is that you're looking for the total number of zeros, and they in any combination it needs to equal the highest degree in the problem.
Yeah.
So if you had one positive and one negative 0, then you would have 4 potential left.
Mm-hmm.
But if you had one negative and no positive, then you would have 5 potential left.
Right.
All right. So for number 15, we're going to look for the sign changes here. And there's and we want to double check 5, 4, 3, 2, 1. It's in order. So there's no sign change until you get to right here, which you showed that from here. And then there's no other sign change after that.
Mm-hmm.
Okay. So there's one positive. So 1 positive 0.
Mm-hmm.
And now what you're going to do, which you did very well down here, you showed it at f negative x down here, which means if I am multiplying, if I'm raising something to the 5th power, then that's going to end up being negative 15x to the 5th, because when you have a negative times a negative times a negative and it's an odd number, it's always negative. This one is even. So if I have a negative and I multiply it, it's going to turn out to be positive. So that's going to remain positive. This one is going to be turn out to be negative. So that's going to change to negative 125x cubed.
Mm-hmm.
And then this one is going to be positive. And then if this one is going to be negative, but a negative times a negative is positive. So then you go back and count the sign changes. And I have a sign change from here to here, so that's 1. And from here to here, that's 2. And then from here to here, that's 3. And then no sign change, no sign change. And then from here, that's 4. So there's 4 potential negative zeros.
Okay.
So if I had 1 positive and 4 negative, but actually it's 4, 2, because you have to go down by zeros. I'm sorry.
No, you're fine.
You have to go 4, 2, and 0. So if there was 1 positive and 4 negative, then we wouldn't have any imaginary.
Mm-hmm.
But if there were 1 positive, 2 negative, then we would have 3 imaginary.
Mm-hmm.
So then that tells me if the highest number of imaginary that you could have is 3, then I pretty much know, because you go down by 2s,
Mm-hmm.
the imaginary are going to be 3 or 1. This is negative, and this is imaginary. Because my total number of zeros has to be. Is that right? Yeah, it has to be 5.
Yeah.
All right. Any questions about number 52? I'm trying to, let me go back for my class. Let me see which one I had on our review for that one. That number 17. So on this, you're going to go from here to here. There's one sign change. And here to here, there's another sign change. From here to here, there's another sign change. There's no sign change from here to here. And then there's another sign change from here. So in the positive aspect, we're looking at 4 positive real zeros. So it would be 4, 2, or 0 for those. And now if I'm going to plug in f of negative x, so if I have negative x to the 5th minus negative x to the 4th plus 3 times negative x to the 3rd minus 2 times negative x squared minus 4 times negative x, running out of room, plus 5. So this is going to be negative x to the 5th. This would be negative x raised to the 4th. That's going to be positive, so that's going to remain negative x to the 4th. Negative x to the 3rd is going to be negative, and a negative times this positive 3 is going to give me a negative 3x cubed. And negative x squared is going to be positive, and positive times negative 2 is going to be negative 2x. And then negative 4 times negative x is going to be a positive 4x and plus 5. So no sign change here, no sign change from x to the 4th to x to the 3rd, no sign change from x to the 3rd to 2x. There is a sign change here and no sign change there. So there's 1. So there's 1 negative. So that tells me if I had 4 positive and 1 negative, it would be no imaginary. But if I had 2 positive and 1 negative, I'd have a potential of 2 imaginary. So there's 2 or 0 imaginaries. For my class, do you guys understand that? Anybody have a question about that? Should I move on to like the next concept then? Do you all feel like I've covered that well enough, or do you need me to do more?
I understand.
Okay. How about you, Brooke? Are you good?
Yeah, I'm good.
Okay. It says state the possible rational zeros for each function. So you're going to use the P over Q, and then we're supposed to find all zeros.
Yes.
So for these, Brooke, is she letting you all use your graphing calculators to pull up the possible, to confirm the possible zeros?
I don't really know. Like, I don't think I don't really know. He hasn't shown us how to do it. So
Okay.
we're allowed to or not.
Okay. All right. Well, you can grab, just for future reference, when I'm talking to my class, I'm talking about the fact that where obviously not where it's an imaginary, because that's kind of the point of the imaginary. It doesn't really cross the x-axis when it's an imaginary. But typically, the point of finding zeros is to find where it crosses the x-axis. And when you're finding the possible rational zeros, it's giving you a place to start.
Mhm.
So the rational zeros for this, like our good old P over Q, where you've got 1 over 2. So all the factors of 1 over all the factors of 2. So you're going to have 1/2 and or positive negative 1. So typically what I tell my class is, start with the easiest one and start with 1 and start with your synthetic division from there.
Okay.
Okay. All right. So I'm going to start with 1 and just pray it works, right? That's what I tell my classes. I'm like, oh, if you're going to start with that, you just want to hope that it works. But you got 2 and then negative 1, negative 2, and 1. I hope that's fairly legible for you guys. Sorry.
Yeah.
So I'll bring down 2, and 2 times 1 is 2. Negative 1 plus 2 is going to give me a positive 1. And then 1 times 1 is 1. And negative 2 combined with a 1 is negative 1. And negative 1 times 1 is negative 1. Praise the Lord. The answer is 0. So I know one of my factors, or one of my zeros, is 1. So that tells me that this polynomial is going to go through the x-axis at 1. And I also know one of my factors is x minus 1. But one of my zeros is 1. I'm just trying to also illustrate what factors mean too. Okay. So now I have this right here is x squared, or 2x squared, my bad, plus 1 minus plus 1x, or plus x minus 1. So now you could either use the AC method and hope that worked, or you could just plug it into the quadratic formula, which works every single time.
Okay.
That's kind of up to you. But I do think this is actually factorable. But just to kind of show the quadratic formula and work with it a little bit more, because that's more than likely going to be on the test. That's what I'm going to do. So I've got A equals 2, B equals 1, and C equals negative 1. So I'm going to plug that into the quadratic formula. Minus 1 plus or minus square root of 1 squared minus 4 times 2 times negative 1 all over 2 times 2. So that's going to be negative 1 plus or minus 1, and then a negative 4 times 2 times negative 1 is going to give me a positive 8 all over 4. So I've got negative 1 plus or minus the square root, that's 9. I hope no one minds if I skip this step. I'm going to take the square root there as 3 over 4. And so now I have negative 1 plus 3, which is 2 over 4. So that's going to be 1/2. Or I've got negative 1 minus 3, which is negative 4 over 4. So that's going to be negative 1. So my zeros are 1, negative 1, and 1/2. So you use those possible rational zeros with the P over Q to find all the zeros So you use synthetic division, and then from there, you can either, if it looks like it's easily factorable, I would factor. If it's not easily factorable, I would just use the quadratic formula.
Okay.
I'm going to flip back over to our review and do that one. I think we have one on there. We're supposed to find all the real zeros for number 15. So once again, I would either A, use my calculator, which I told mine they could do that. I'm going to use Desmos just so that I can show how that works. I had to write down the problem. Can y'all see? Oops. Can you see where I'm switching to Desmos, or do I need to reshare my screen?
I can see it.
Okay. Are you the only one left with me, or do I have others?
No, there are a few more people in here.
Okay. Oh my. Okay, so when you graph it, you can see where they're going through. Oh, we're going to get a fun zero. You can see where they're going through. And this obviously, I can tell by looking at these that these are going to be those conjugate pairs. Yay. And then I've got one solid zero at -4. And I'm going to explain why we do that. So I know there's a good one at -4. So let's go back. A good zero at -4. And these are more than likely, I'm just saying, not positive, but these are more than likely going to be where I end up with using the quadratic formula, and they're going to be irrational. So when what I mean by that is if I were to find all the real zeros, starting with P over Q, taking all of the factors of 20 over all of the factors of 1. So all the factors of 20 are plus and minus 20, 10, 5, 4, 2, and 1. So each one of these numbers all over 1. And a lot of times I would start with 1. Okay? And then I might go to -1. And then I would move to positive or -2. So I would done synthetic division a minimum of 4 times before I would have ever hit 4. So the value of being able to go to your graphing calculator and trace and find where a solid zero is, it kind of eliminates having to use the synthetic division so many times. Does that make sense to you all?
Yeah.
Okay. So what I'll do then, since I know 4 is absolutely a zero, a rational zero, because that was one of the rational zeros. 4 is one of the rational zeros. So I'm going to use that with synthetic division to get this to a quadratic where I then can use the quadratic formula. So this is 1, 4, -5, and -20. So I bring down my 1. 1 times 4 is 4. That's 0. 0 times 4 is 0. This is going to be -5. -5 times 4. Did something wrong. Oh, I know what I did wrong. This is a -4. It helps if you use the right 4. So if I go back and do -4, ooh, and it helps. Okay, so that's going to be, okay, 0. +20. There we go. I knew what I wanted it to be. I can tell by the way I did my numbers. But anyway, all right. So now this is actually going to be a quadratic. X squared, ooh, -5. So, and actually this is better than having to use the quadratic formula because I'm just going to set that equal to 0. So I've got x squared equals 5 and take the square root of both sides. So I've got x equals plus or minus the square root of 5. So my zeros, when it says find all zeros for that, it's going, my answer would be for 15, it's going to be 4 and plus or minus the square root of 5. For my class, are there any questions about that?
I have a quick question. So I was doing number 13, and you had to use the quadratic formula to solve it, and I came up with like this really weird answer.
Okay.
So I solved all the way down using the quadratic formula, and I came up with -9 plus or minus 6i divided by 2.
Okay. It might be, you know, sometimes the answers are ugly. Let me check my answer sheet on it. If not, I can just work it out and see if we get the same thing. Because Lord, my dog is playing with her toy. Sorry about that. Okay. Let's try it because this has the answer down as -6 and -3. So let's just see.
Okay.
For the other zero. So let's just see. So we've got 1 and 5 and -18 and -72. So, and 9 times it's 36. This will be 18. So did you get this? X squared plus 9x plus 18?
I did get that.
Okay, and then that factors down to x plus 6 and then x plus 3. Because two factors that multiply together to give me 18 are 6 and 3.
I thought you had to solve using the quadratic thing.
Well, you could, and we could do that, but sometimes if they're easily factorable, I just go ahead and factor them.
Okay.
If I recognize that they're factorable, but if not, your A would be 1, your B would be 9, and your C would be 18. So, and you use that?
The quadratic, I did. I don't know. I'm really bad at the quadratic formula, so I must have messed something up.
Okay, well, you know, there's a lot of moving parts in the quadratic formula, that's for sure. But I can work it if you would like to see it done.
Can you work that out real quickly, please?
I absolutely can. So minus minus b, because it's always good to see the quadratic formula worked out for sure. So this, everyone will benefit from that. Plus or minus, and then we've got 9 squared, which is 81. I hate skipping steps. I hope that doesn't bother anybody. Minus 4 times 1 times 18. All over 2 times 1. And then this should be 72. So 81 minus 72 is 9, right? No?
Right.
Yes. Minus 9 plus, and then the square root of 9 all over 2. So we got negative 9 plus or minus 3 over 2. So then you've got negative 12 over 2, which is negative 6, or you've got negative 6 over 2, which is negative 3.
Okay. I understand. I messed up along the way there.
Okay.
Thank you.
But there, like I said, there's no problem. There's a lot of moving parts. And what I was glad about for that one is you guys got to see, once you use synthetic division on one of the zeros or solutions that they have given you, if you recognize that it's factorable and you want to do it that way, you're welcome to. But the quadratic formula works every single time. So whether you're getting normal numbers, which negative 6 and negative 3 are pretty normal, and I think we had some earlier where we had a 1/2 and a 1, you know, but you can see that the quadratic formula works every single time. Whether you get normal numbers or, you know, the possibility there will be some irrational ones, you know, so.
Okay. And then while you're on this page, can you do number 20?
Yes.
Thank you.
Okay. So using a graphing calculator. So once again, I'm going to go ahead and use Desmos for this. We're going to identify the x-intercepts and the points where local maximums and local minimums occur. So let me write the problem down. I did type it right?
Yes, ma'am.
Okay, so the x-intercepts, oh, they made some of these fun. Once again, that looks like that's the same exact number that we got for the square root of 5, which that makes perfect sense.
Okay.
And another way to be able to find those out, Rachel, is to set each one of your factors equal to 0 and then solve.
Oh, that's how you can find it?
Yes, ma'am.
I didn't know that. Okay.
Yeah, that should be, each one of your factors can be set equal to 0 and solve when it's that easy. I mean, those are pretty easy ones. So that's how you find that. And then your local maxima and minimas. This is a local, and that's going to be a minima. Okay.
Okay.
And it's always your y value. And that's a local minima. So it's -4. Okay.
Okay.
And this is a local maxima, and it's a 5. So it's where the turning points on a graph are. And if it's a low point, it's a minima. If it's a high point, it's a maxima.
Okay.
'Cause
I understand the
it's
minimum
higher
and maximum stuff. I just didn't get how to like find where your x coordinates are if they're not directly on there.
Yeah, well, and that is definitely one of the ways to do that, because your solutions or your roots or your zeros are always, since this was in factored form, the factors are always going to be where the zeros are if it's a rational or even an irrational number. Obviously, if it's an imaginary number, you know, like you've got an imaginary one, it's not going to be anywhere on the graph. Those would not be like if you would have had x squared plus 5, that would have given you an imaginary number. So that would not have been a 0, because obviously an imaginary number isn't going to hit this coordinate plane. Because remember way back, I think in was it chapter 1? Haven't we graphed imaginary numbers?
I think so.
Yeah. So it's not the normal coordinate plane.
Okay.
Okay.
Thank you.
And poor Bella, I haven't forgotten about you on number 21 either.
I think Bella left.
Oh, bless her heart. I'm going to have to work it out and then send it to her.
Okay. And then I have one more question before I go. So on the front page, number 4, the synthetic substitution, I know how to do that, but I didn't get a remainder of 0. So do I just leave a remainder? Because it says evaluate.
Yes. Okay. Let me kind of remind you guys a little bit about synthetic substitution. When you're using synthetic substitution, this is kind of where we get the concept behind synthetic division. When you're using substitution, whatever that remainder is actually the answer. So if you were doing direct substitution, you would get that. Like if I were to plug a 2 into this equation right here, whatever you got as the remainder would be the answer.
Oh, okay.
So you should have gotten a remainder for that.
Okay, that makes sense. Thank you for that.
No problem. What was your remainder?
Well, I actually erased my whole thing because I thought I did it wrong. So I had to redo it. That's okay.
Okay, I'm pretty sure if I kind of moved a lot of the questions around, but I think the answer for this one should be -2.
Okay.
So if you want to write that down and go back and
that's actually what I got. I see it now.
Okay, yeah, the answer is -2 for that one.
Thank you so much.
Yeah, that's the cool thing about synthetic substitution is that we learn that first, so that later on, when you get a remainder, you kind of understand, okay, well, that wouldn't be a factor, but actually, if we would have substituted this number into the equation, it's actually, to me, I like synthetic substitution better than I do really plugging in a 2 and then raising it to the 4th power and multiplying it by 2 and doing all that other stuff. I think synthetic's way easier.
Yeah, I do too.
So anyway, yeah, number 3 and 4 were kind of to show you how much easier synthetic is.
Okay, thank you.
No problem. Okay, Brooke, are you still with me?
Yeah, I'm still here.
Okay, baby girl. All right. Let's see. Let's go back and look at some of these others. Do you want me to keep doing the finding all the zeros? Just work through all of those.
I worked 56 and 57, and I checked them on the answer key, and I got them right. I just was wondering if you could work 58.
Absolutely. I would be happy to. So we're going to find all the real zeros. Good for you getting that done, though. And good for you getting it right.
Thank you.
All right. So we're going to, the possibilities is going to be our good old P over Q.
Mm-hmm.
And so then we've got all the possibilities. So we got plus or minus 1 and then plus or minus 2. All the factors of 2. So we know that it can be, let's see, it can be plus or minus 1, and yay, plus or minus 1/2. Pretty excited about that. But we're gonna try 1 first and then hope and pray. Did you get lucky on them, and was one a possibility, or did you have to do synthetic a lot on 56 and 57?
For 56 and 57, it worked with one, but I'm on 58 and I worked one and I got like two. So
Ugh. Have you done -1? So
no,
maybe I
that's
should.
I didn't know where to go after that.
Okay, well, since one didn't work, we're going to go with -1. Thanks for the heads up.
Yeah, you're welcome.
All right, so we'll bring down our 2, and 2 times -1 is -2, and 1 plus a -2 is -1, and -1 times -1 is a +1, and then -2 minus 1, that's going to be a -1, and -1 times -1 is a +1, so that's a 0. So one of our zeros is -1.
Okay.
And then we know that's going to be 2x squared minus x minus 1, which, if I'm not mistaken, isn't that what we got over here?
For which one?
Maybe it wasn't. Number 55? Didn't we get 2x squared minus x minus 1?
Yeah.
Or no? Yeah. Did we?
Oh wait, I think it was plus x minus.
Oh, well, there's your little hiccup. All right. So what I would do then is we're going to plug this into the quadratic formula. You could factor it also if you wanted to, or try to factor it. I don't know if it'll work. So, it's better safe than sorry.
Yeah.
2, -1, and -1. So I've got a -1 for my b, plus or minus. And then -1 times -1 is a +1, times 4 times 2 times -1, all over 2 times -1. So that's going to be 1 plus, and then this is going to be 1 plus 8, which is going to be 9, and the square root of 9 is 3 over -2. So that's going to be 4 over -2, which is going to be -2. And then we're going to have 1 minus 3, which that's going to be -2 over -2, which is 1, which that's weird if 1 didn't work because it appears to be one of the ones. So it looks like the answer. What are the answers? What's the answer to number 58?
It's
Because I get -2, -1. Oh, -1 twice.
She said for the zeros, it's
or 1, actually.
-1 and 1.
What is it? For number?
She said for 58, she said the zeros are -1/2, -1 and 1.
Huh. What did I know what I did wrong. My bad.
Synthetic.
I know what I did wrong. I see what I did wrong. That was supposed to be a 2. That changes it completely. So that's a 4. So that would make, I don't even know where I got a -2. So that's a 4. So it's -1, right? For 1.
1, 1, negative.
Here's my -1/2.
Yeah.
Yeah, I think she sent those. I saw her post those answers.
Yeah.
Okay. All So the end behavior, it looks like you did really good on the end behavior, but I want to talk about that unless, is there anything else you want me to, or you feel good about that?
No, I wanted you to go.
Okay. What I like to do, and I think what the video said originally about this and how I like to think about the end behavior
Mhm.
is I like to not get overcomplicated with the fact that this degree is higher.
Okay.
You know, basically this is, going to make up to 4 turns on the graph.
Right.
Okay. So when I graph that thing, it's going to be like, you know what I mean? It's going to look squirrely. I think that was more than 4 turns, but basically the point is that it's going to turn a lot.
Mhm.
But what I like to do is think of that is 5 is an odd number.
Right.
So it corresponds to the line because the line is the simplest of all odd functions
Yes.
because it's x to the 1. So the leading coefficient is positive. It's a positive 1.
Mhm.
So that means, remember good old slope from a line? When you had a positive slope, the line went like this.
Mhm. Yeah.
Well, believe it or not, this function is going to look like this, except with 4 turns in the middle.
Okay.
It would look something like, that's
Mhm.
more than 4 turns. Once again, I'm not good at drawing 4 turns apparently. But see how the end behavior over here mimics this end behavior?
Yes.
Like it starts. So that means as x is going this way, which is negative infinity. So
Mhm.
as x approaches negative infinity, y approaches negative infinity because it's going down.
Okay.
So as x goes left, y goes down. So they're both approaching negative infinity. But as x goes toward the right and gets bigger, because this is actually getting wider and wider as it goes out.
Uh-huh.
As it goes up, it's going out. So as x approaches positive infinity, y is approaching positive infinity.
Okay.
And she doesn't have any here with negative coefficients. So I can't, there isn't a good example there of, of that. But if let's just pretend number 61 was negative for just a minute.
Okay.
Well, actually, just work them as they are first and then not confuse you with the other details. But just in case, I want to make sure you understand. Okay, so this one, this cubic one, that means there's going to be 2 turns in it, possibly.
Okay.
But it's still an odd function, so it's still going to look like that. It's still going to mimic that line. So as x approaches negative infinity, then y approaches negative infinity.
Right.
Because as it's going this way, it's also going down. As x approaches positive infinity, y over here, as it's going this way, it's also going this way.
Right.
So y is approaching positive infinity. All right, on number 60, this is an even function. Actually, we know that it's a parabola and it's just shifted down 4 from our parent function.
Right.
So it's going to look like that. So as x approaches, so this actually, as x is going this way, it's still going up. So as x approaches negative infinity, y is actually approaching positive infinity because it's going, even as x goes toward the negative, it's still going up. And as x goes to positive infinity, y is still going up.
Yes.
So as x approaches positive infinity, y is also approaching positive infinity.
Okay.
And the same, and it has the same behavior on number 62 as 60.
Yeah.
Does that help?
Yes, ma'am, it does.
Okay. Do you want me to do 62?
No, I think I got it.
Okay. Are there any others that you want me to do?
I'm looking through. I don't think so. Let me make sure. Oh, there was one. It was number 7, so I didn't send it to you. But it's like we were talking about like simplifying when they have like exponent. So I was wondering if
Okay, you want to just tell,
yeah,
you want to just read me the problem?
yeah. So
Okay.
it's m to the third.
M to the
M
third.
yeah, times n to the fourth. And then times and then there's a parentheses 2m to the fourth. Times n to the third. And then there's another parentheses. And then to the fourth.
Did I write it correctly?
Yeah.
Okay. So what I would do is just work inside the parentheses first.
Okay.
So I've got 2 to the fourth,
Mm-hmm.
which that's 2 times 2 times 2 times 2, which that should be 16.
Mm-hmm.
And then m to the fourth raised to the fourth, which that's going to be m to the 16. And then n to the third raised to the fourth is going to be n to the 12th.
Okay.
And so now I don't have any coefficients other than 16. So I've got basically 16 times 1 times 1.
Right.
And then I've got m to the third times m to the 16th, which is going to give me m to the 19th because I just add them at this point.
Okay.
And then n to the fourth times n to the 12th is going to be n to the 16th. So that would be my final answer.
Okay. I like multiplied the powers instead of adding them.
Oh, okay. The only time you multiply the powers is at this point right here.
Right. Yeah.
And then the rest of them you just add.
Okay.
That's why you kind of want to handle that first.
Mm-hmm.
All right. Are there any other questions?
I don't think so. Thank you so much, Miss Sparks.
Not a problem.
Have a good day.
Not a problem. Oh, you have a good day as well.
Thank you.
Mm-hmm.
Miss Sparks.
Yes.
So I'm going through all my work that we have to turn in tomorrow, and I didn't get the what is it? Let's see. The 2.4 practice A.
Oh, okay. I can send that to you.
That's the only thing I
Are you
didn't have. Yeah. That's what I
Okay.
needed.
Okay. Were you absent? I don't remember you being.
I couldn't find it where I keep all my worksheets.
Okay. Well, I definitely can send it to you. I'm trying to think. Let me go ahead and email that to you. Do you have other questions? Or you just need
some questions on what is it? I think it's the 2.5 riddle worksheet.
Oh, okay.
I know this is from a while ago, but I
had that's
weren't finished on it.
Okay, you did say 2.4 practice A, right?
Yes.
I just sent it to you. Let me make sure that we got it. And then the riddle. The riddle one. And then I still need to work out that one for Bella. And then I'm going to send that to her too. Okay. I don't know. Let me see if I have the riddle. I don't remember. I feel like I have it. I feel like this is it. I hope this is it.
All right, I got it.
Okay, good.
Thank you.
Uh-huh. All right. Which one?
So I did all the ones. So 1, 2, 3, 4, 5, 6, 8, and 10. I did all of those because they were synthetic. But then the long division ones are what's kind of tripping me up.
Okay. All right. Let's work some of those then.
So is long division going to be on the test?
Let me see. I've been trying to look because I'm trying really hard to like focus the math lab on what I know is going to be on there.
Okay.
You know what I mean? Well, the instructions actually say divide using polynomial long division or synthetic division, but all of the like divisors, if you will, are like 1, 2, 4, 6, 5. It's not the long division part. Do you want me to work a long division with you?
Yeah, because I'm just not. I looked at the videos, examples. I'm just not really getting it.
Okay. It can be a humdinger, that's for sure. So that's an understandable, and just because like I was talking to Rachel about, there's just a lot of moving parts, you know.
Yeah.
So I'm gonna actually go over here to a blank sheet, and I'm doing number 3. Okay, that's the one I wrote down because to me it was the hardest one on there.
Because I've got that one.
Oh, you did? Okay. I think I might have done that one in class, actually.
Yeah, I think you did too, because I have it written down on the back.
Okay. All right. Well, let me do number 7. That's the next one, right?
Okay, yeah, I think that's about the standard. Or they're all kind of like that. So yeah.
Do you have that one done?
I don't know.
Okay. All right. I just want to make sure I'm not working one that you have done. Okay, so 2x to the 4th plus 8x to the 3rd minus 5x squared minus 4x plus 2. And then x squared plus 4x minus 2. So what I'm looking for is this is always the area you want to focus with, is that leading number. And what you want to do is you want to look for what can I multiply this number by to give me this. That's where you really want to focus, okay? So what would it take to multiply? So it would take me multiplying x squared by 2x squared to get 2x to the fourth, right?
Yes.
So if I had this, I would have this.
Okay.
So I'm going to put 2, and then just like place value, back when we were learning long division 10 years ago, you want to put your term in the place that it belongs. So you would put that 2x squared above the x squared term.
Okay.
Okay. So now I'm going to multiply 2x squared by each of the 3 terms in my divisor. So 2x squared times x squared is 2x to the fourth, which is exactly what I wanted, because I'm trying to eliminate that term first. Now, 2x squared times 4x is 8x cubed. And then 2x squared times negative 2 is negative 4x squared. So I've got 2x to the fourth minus 2x to the fourth. So that's 0. That was our whole goal. But I also have 8x cubed minus 8x cubed. So that's 0 as well. But I have a negative 5x squared minus a minus. So that's actually going to turn this into a plus. Okay. So negative 5x squared plus 4x is going to give me a negative x squared. And I'm going to bring down my 4x. And I'm actually going to go ahead and bring down my 2 just because I know I've got 3 terms here. So I know whatever I multiply that by, it's going to give me multiples. Does that make sense? It's going to give me 3 terms.
Yes.
Okay. So what do I need to multiply x squared by to give me a negative x squared?
So an
Like
I get
one.
negative 1.
Right. So in order to keep it just like I told you, I need to put that term above my constant because it's a constant. And the whole reason this happened is because this and this canceled out. So I literally skipped over a whole section. Does that make sense?
Yes.
Normally that wouldn't happen. Normally you'd end up with some kind of x cubed term. So, but if I multiply negative 1 times x squared, I get a negative x squared. And if I multiply a negative 1 times a positive 4x, I'm going to get a negative 4x. And if I multiply a negative 1 times a negative 2, I'm going to get a positive 2. But I'm subtracting this. And so if I do a minus minus, this actually turns to a plus, this turns to a plus, and that turns to a negative. And then I can get rid of that. So this turns to 0, this is 0, and this is 0. So my answer is this with no remainder.
All right.
But as far as the test is concerned, tomorrow you can use synthetic.
Because that was what I was wondering. Like, most of the ones on this are synthetic. You can use synthetic. I just wondered if it was going to be like that on the test.
No, but if you ever move on to calculus, and I think actually pre-calc has polynomial long division in it, and I'm not sure if Calc 1 has it, so I don't know what you want to be, but Calc 2 I think has it. I can't remember.
Okay.
So it's definitely a skill that you need to have. And I liked the riddle sheet just because these didn't have any remainders. So that's why I picked the riddle sheet as the homework.
I also wonder, can you do 13 on the back of it? Because that one was pretty long.
13 on the back of the riddle sheet?
Yes.
Oh, yeah. I couldn't imagine why you want me to do that. It's actually, it looks ugly, but it's not as bad as it seems. I promise. I think what I might try to do, I think I'll run out of space if I do that. Never mind. Oh, I just closed that. Well, I may not have any choice. I think I'm going to have to do it here. Okay, so 2x to the fourth minus x cubed plus x minus 12 being divided by x cubed minus 2x plus 3x minus 4. So once again, what do I have to multiply x cubed by to get 2x to the fourth? So that's going to be, yeah, 2x. Yes. Is that what you said? Good
I didn't
job.
say anything, but yeah, 2x, yeah.
Oh, okay. I'm sorry. I thought you did. I apologize. So 2x. So 2x times x cubed is 2x to the fourth. And then 2x times negative 2x. I forgot my little. Oh, look. Oh, that's tricky. That was a trick. Look, right here, you can combine those. I don't know if that was a typo or what, but that should be x cubed.
Oh, okay.
Plus x. I don't know if that was a typo, if that's supposed to be x squared or not. Minus,
Okay.
I don't know. That's interesting. We'll see what happens. Very interesting. All right. Well, I don't know if it was supposed to be a typo and that was supposed to be an x squared. I can't remember, and I have no notes in my answer key. Let's see. It's 2x plus 3. You know what? I think that's supposed to be f squared if it's 2x plus that. I'm almost positive. We'll work it that way anyway. Looking at the answer key, I think that's what it's supposed to be. So that must have been a typo. Okay, and then 2x times, maybe not, negative 2x is going to be a minus 4x. And then 2x times 3x is a positive 6x. And 2x times 4 is a negative 8. This is all a big experiment. Those turns out to be 0. And then you've got x cubed, negative x cubed minus a minus 4x is 3x. Cubed. And then this is going to be a minus 5x. And that's going to be a minus 4. Oh, I messed you up again, Matthew. Because I didn't put a placeholder here either. No wonder you wanted me to do this one. I have to start over. Are you ready to kill Miss Sparks?
Actually, I wrote it out wrong, so I just had to erase mine.
Oh, you did?
Yep.
And then I have to figure out, you know what? I'm probably going to have to work this one out for you and email it to you, but I will give you the answer now just because I forgot to put the placeholder, but I really need to figure out whether number on the bottom part, if that's supposed to be, if I was supposed to combine, because so I'm going to have to work it two ways no matter how I look at it. So let me just give you the answer for that one, and which is 2x plus 3. Did you see it?
Yeah.
Sorry. Okay. Let me give you the answer for that one, and then you can just put it. I'll understand. I'll put a note by it. But I need to work that one both ways to figure out. I know I need the placeholder, which I did forget to check, but I need to figure out if this was a typo or not. So I have to work it as with just an x in it, and then I'm going to have to work it with 2x squared.
Okay.
And I'm not going to put you through that since you're already anti-long division anyway.
All right.
Is there any other questions that you have?
I don't think so.
Okay. How are you on the chapter test B? Was it too bad?
Not really, no.
I didn't.
Really, as long as there's no long division, I'm all right.
Oh, okay. And I'm going to post the answers too. I'm getting ready to post all of those for you guys.
Okay.
Okay.
All right.
All right.
Thank you.
You're welcome. Thank you.
Bye.
Bye-bye.